Hello and welcome to another GCSE Maths walkthrough, and in this video I'm going to be looking at the foundation tier paper, and it's going to be the first paper, so paper 1, which is a non-calculator paper. I will also be doing paper 2 and paper 3, which are both calculator papers, so please after this one please check those videos out as well. So in the video description I've put a link to this paper, so I encourage you to download that paper and have a go at it yourself alongside me, and make sure you have all the correct equipment as well before you go. So make sure you've got a ruler, a pair of compasses, a protractor, a pen, a pencil and a rubber. They put a razor here, but obviously I'm doing this in the UK and we like to use rubber instead of a razor. So, without further ado, let's get cracking. Okay, so question number 1. Change 530 centimetres into metres. So, we need to think about our conversions. So, how many centimetres are there in a metre? Well, there are 100. So, 100 centimetres is equal to 1 metre. So, if we've got 530 centimetres, how are we going to convert that into metres? Well, we're going to divide by 100. To go from 100 to 1, we just divide by 100. So I'm just going to divide this figure here by 100. So 530 divided by 10 is 53. We just move the decimal point one place to the left if we divide by 10. But if we're dividing by 100, we move it 2 places to the left. So it's now here. So our answer is 5.3. So it's going to be 5.3 metres. So if we write it down here, 5.3, we don't need to write metres because it's already been given to us here. Question 2, how many minutes are there in 3 1/4 hours? So this time we need to convert between minutes and hours. So first of all, let's think about how many minutes there are in an hour. And there are 60. So there are 60 minutes. I'm just going to write min for short. That is equal to 1 hour. So we've got 3 1/4 hours. So what I'm going to do is I'm just going to split 3 1/4 up. So 3 1/4 hours. Well, that's exactly the same as 3 hours plus 1/4 of an hour. Okay, and I think if we just split it up, it makes it a lot easier. So first of all, how many minutes are there in 3 hours? Well, in 1 hour, there's 60 minutes. So in 3 hours... well, there's just going to be 3 times as much. So if we just multiply that by 3, 60 times 3, well, 6 times 3 is 18, so it's going to be 180. So there are 180 minutes in 3 hours. So let's write that down here. So 3 hours is 180 minutes. Plus 1/4 of an hour. Well, I don't really need to do any mathematical calculations. I know that if you go 1/4 of the way round a clock, well, that's 15 minutes. So plus 15 minutes. You could just divide 60 by 4 and you'd also get 15. So we've got 3 hours, which is 180 minutes, plus 1/4 of an hour, which is 15 minutes. So our total, we're just going to add these two together and that gives us 195 minutes. And again, in our answer box, we just need to write in 195. We don't need to write minutes because it's already been given to us here. Question 3, write 4.4354 correct to 2 decimal places. So let's just write our number down underneath here, a bit bigger. 4.4354. So we're rounding this to 2 decimal places. So first of all, what is our second decimal place? So this is our first decimal place. This is our second decimal place. So if I just put a dashed line here, so it's 4.43, or it's going to round up to 4.44. So to decide whether we round this up or down, we look at the digit next to sort of after our second decimal place. So because this is a 5, we have to round up. Okay, if this is less than a 5, we round down. If it's 5 or greater, we round up. So we're going to round this up, so it's going to be 4.44. Our answer is 4.44. Question 4. Write 0.9 as a percentage. Okay, so converting between decimals and percentages. So whenever we convert a decimal to percentage, we just multiply it by 100. The word percent means per 100. So we just need to multiply our decimal by 100. So we're going to do 0.9 times 100. And again, every time we multiply by 10, we move the decimal point 1 to the right. So if we multiply it by 10, that becomes 9. If we multiply it by another 10, that becomes 90. So our answer is 90. So that is 90%. So we just write 90 in here because the percentage symbol is already given to us. Question 5. Work out -3 cubed, or you could say -3 to the power of 3. Now you need to be really careful with this because a lot of people make the same mistake and they will do -3 times 3. A lot of people think that we just multiply -3 by 3. This doesn't mean times 3, it means times this number by itself 3 times. So this is not correct. So we're going to multiply it by itself 3 times. So it's going to be -3 times -3 times -3. That's what this means. So if we just break it up, let's first of all concentrate on this part. -3 multiplied by -3, well, that is +9, because when we multiply two negative numbers together, that turns into a positive. So we've got 9 times -3. So what is 9 times -3? Well, 9 times 3 is 27, but we've got a negative here, so it's -27. So our answer is -27. Question 6. Here are 4 cards. There is a number on each card, which we can see. Write down the largest 4-digit even number that can be made using each card only once. Okay, so first of all, let's just think about the largest number we could make. So the largest number would be if we start with a 5, and then a 4, and then a 2, and then a 1. That's the largest number we can make using these cards. But notice it is not even because it ends in a 1. It has to end in an even digit for it to be even. So we can just change the 2 and the 1 around. So instead of 5, 4, 2, 1, we can say 5, 4, 1, 2. And now this is even. So this is definitely the largest digit, number we can make that is even, and we've only used each card once. We can't do 5, 5, 5, 4, because although that's larger, we've repeated the 5. So this would be our answer. So it's 5, 4, 1, 2. Okay, part B. Write down all the 2-digit numbers that can be made using these cards. Now, whenever you're asked to write down all of something, try to be really systematic about it. Okay, so we've got the numbers 1, 2, 4, and 5. We're only making a 2-digit number. And we can only use each card once. So we can't have 11. That would not be a valid option because there's only one 1. Okay, so let's think about, let's do it from the smallest to the largest. So we're doing it systematically. So the smallest number we could make would be 12. Okay, the 1 and the 2. Let's keep the 1, and now let's just move up 1. So the next one would be 14, and then the next one would be 15, and that's all of the numbers we can use that start with a 1. So now let's move on to the 2s. So we could say 21. Again, we can't use 22, but we can use 24, and we can use 25. That's all of the 20s. Now let's move on to the 40s. So we can use 41, we can use 42, and we can use 45. And then finally, let's move on to the 50s. We can use 51, 52, and 54. So there are 12 answers in total. So all of these ones here. Question 7. The table shows information about the sports that some students like best. So we've got 4 different sports here and boys and girls. Draw a suitable diagram or chart for this information. So we've got the grid that we're going to put our chart on, and this is worth 4 marks. So the first thing to think about is what type of diagram are we going to draw? Now, whenever you see categories, you should be drawing a bar chart, okay, not a line graph. So we're going to put the frequency along the y-axis, so how many people like that particular sport, and then the sport along the x-axis. So first of all, let's think about the frequency. And I can see that the largest frequency is 15. So it has to go up to at least 15. So I think each of these, if each of these is 1, that should work. So 1, 2, 3, 4, 5, 6. Let's just check we're doing it in the right place. That would be 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, it does work. So they want you to do it like this. Okay, try not to use these small ones as ones, so 1, 2, 3, 4, 5, because obviously you're not going to use the whole space available. Try and maximize the grid that you've been given. So let's just label this. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. And we need to make sure we give it a title. So this is frequency. That's our frequency axis. And then on the x-axis, we're going to have our sports. But notice we're not going to have 4 bars. We're actually going to have 8 bars because each sport is broken down into boys and girls. So let's first think about hockey. So hockey boys, there were 3. So let's say that this is hockey boys. I'm going to do it in between these 2 points here, and we're going to go up to 3. So make sure first of all you get your ruler out, okay, to make sure that you are being as accurate as possible. So I'm just going to get my line tool out, and I'm going to go up to 3. That is a bit thick, so let me just make it a bit thinner. Let's make it even thinner than that. Okay, I think that's good enough. Okay, so I'm just going to draw lines to complete this bar. So this is my hockey boys bar. Okay, so that's good enough. So it goes up to 3. And then next to that, I'm going to do hockey girls. Hockey girls. So I'm going to do exactly the same thing. Get my line tool out, and I can see that the girls, there are 6 of them. So I'm just going to go up to 6, like so. And if you want to fast forward a bit, because this can be a bit slow. Actually, what I'll do is I will fill in the rest of these bars. So first of all, I'll fill in the hockey girls bar. And now I've done the hockey group, let's move on to the tennis group. And I'm going to leave a space. So I'm going to leave a bar's space just so it's a bit clearer. So now I'm going to go on to tennis. And I'm going to do the tennis boys first. So I'm going to do the tennis boys here. And then next to that, I'm going to do tennis girls. So if you just, I'm just going to skip along to the end of that. So you can see I've done the tennis group now with the boys and girls. And again, just like before, I'm going to leave a space to do my football people. And then I'm going to leave another space and I'm going to do my golf people. So I'm going to skip along to that right now. Now, this question here is worth 4 marks. So I love these sort of questions because it's a really easy way to pick up marks. You'd get 1 mark just for your correct labelling. So making sure that you've labelled the sports and the genders correctly. And doing this is absolutely fine. You don't need to write out the whole name as long as it's clear what your labels are. You get another mark for the correct scale on your axis. So you notice that I've gone up evenly on my scale. And you'd get a further 2 marks if you've done everything correctly. So if you've put the correct heights on your bars, you'd get 2 more marks. If you've made 1 mistake with the heights of your bars, you'd still pick up 1 mark for that. But 2 marks if you do it all correctly. Question 8. Bernard says, when you halve a whole number that ends in an 8, you always get a number that ends in 4. Write down an example to show that Bernard is wrong. Right, okay, so let's think about numbers that end in 8. So what about 18? So if we halve 18, 18 divided by 2, well, that gives us 9. So he's wrong straight away. So we just need to use this as an example. So we can just say that 18 or half of 18 is 9. Now the second part says, Alice says, because 7 and 17 are both prime numbers, all whole numbers that end in 7 are prime numbers. Is Alice correct? You must give a reason for your answer. So similar to before, if we find a counterexample, then we've proved that she's wrong. So 7 and 17 are both prime numbers. What about the next 2-digit number that ends in a 7? So 27. So 27, is that prime? Well, no, 27 is not prime. So we can say that 27 is not prime. and then I'm just going to put in brackets 9 times 3 equals 27. So because 27 is not prime, that means that Alice is wrong. So 27 is not prime, so Alice is wrong. And we're done. Question 9. Work out 247 times 63. Now, I appreciate that you're all from different schools, different countries, so there's probably a few different methods that you'll use. I'm going to just go through two methods. So I'm going to do the traditional method. This is the way that I was taught at school many years ago. So 247 times by 63. So I do it the traditional way. So I start off with the units. So 7 times 3 is 21. So we do the 1 here, we carry the 2. And then 4 times 3 is 12. Plus 2 is 14. So we put the 4 there, carry the 1. And then 2 times 3 is 6. Plus the 1 is 7. So we've dealt with the 3s. Now we're going to move on to the 6s. And because we're in the tens column, we have to put a 0 here. So now we do 6 times 7. Well, that's 42. So the 2 goes here, carry the 4. 6 times 4 is 24. Carry the 4, that's 28. So we put the 8 there and the 2 there. And then 6 times 2 is 12. Plus the 2 is 14. So we put the 14 there because it's the last one. And now we just need to sum these two numbers together. So 1 plus 0 is 1. 4 plus 2 is 6. 7 plus 8 is 15. So 5, carry the 1. 4 plus 1 is 5. And then 1 plus 0 is just 1. So our answer is 15,561. Now the other method is the grid method. So we can break 247 down into 200 plus 40 plus 7. So that's 247. And we can break 63 down into 60 and 3. And now we just multiply all of these numbers together. So that's why it's called the grid method, because it is a grid. So 200 times 60, well, 2 times 6 is 12. And then we've got 3 zeros. So it's going to be 12,000. 40 times 60, or 4 times 6 is 24. And we've got 2 zeros. 7 times 60, 7 times 6 is 42, and we've got 1 0. 200 times 3, well, that's 600. 40 times 3 is 120, and 7 times 3 is 21. And now we just need to sum all of these together. So we've got 12,000, 2,400. Make sure you line up your place values correctly. We've got 420, 600, 120 and 21. So this column, that's 1. Here we've got 2, 4, 6. Here we've got 4 plus 4 is 8. 8 plus 6 is 14. Plus 1 is 15. We carry the 1. 2 plus 2 is 4. Plus 1 is 5. And then 1 plus 0 is just 1. And luckily, we got the same answer. So I did do it correctly both ways. So our answer is 15,561. Question 10. An American airline has a maximum size for bags on its planes. The diagram shows the maximum dimensions over here. So we've got the maximum height, depth and width. And it's given to us in inches. Chris has a bag. It has a height of 50 centimetres, a width of 40 centimetres and a depth of 20 centimetres. And we're given a conversion here between inches and centimetres. And we need to work out, can Chris take this bag on the plane or is it too big? You must show your working. So at the moment we've got the measurements for the maximum size of our case in inches, but Chris's measurements, or Chris's bag's measurements, are in centimetres. So we're going to have to convert either all of them to inches or all of them to centimetres. And what I think I'm going to do is convert them all into centimetres. So if we look at our conversion, 1 inch is 2.54 centimetres. So to go from inches to centimetres, we need to multiply it by 2.54. So we've got the height. So the height is going to be 22 multiplied by 2.54. The width is going to be 14 times 2.54. And finally, the depth, well, that's going to be 9 times 2.54. Now we need to remember that this is a non-calculator paper, so we can't just type all of this into a calculator. We're going to have to work out what each one is. Now I think I'm going to start with the easiest one first, so the depth, because it's just smaller numbers. So we've got 9 times 2.54, so let's do it up here. So I'm just going to do 254 times 9, and then I can deal with the decimals. So 4 times 9 is 36, 5 times 9 is 45, plus 3 is 48, and 2 times 9 is 18, plus 4 is 22. And we've got 2 digits after the decimal, so we should have 2 digits after the decimal. So that is going to be 22.86 centimetres. If we compare that with the depth of Chris's bag, well, that's less than this. So that is absolutely fine. The depth is fine. Now let's think about the width. So we've got 14 times 2.54. So let's do 254 times 14. So 4 times 4 is 16. 5 times 4 is 20, plus the 1 is 21. 4 times 2 is 8, plus 2 is 10. Now we're dealing with the tens, so we need to add a 0. 1 times 4 is 4. 1 times 5 is 5. 1 times 2 is 2. Add them together, so we get 6, 5, 5, 3. And again, we've got 2 digits after our decimal, so we need 2 digits after our decimal. So our answer is 35.56 centimetres. Again, let's compare that with our width. Now we run into an issue here because Chris's bag has a width of 40 centimetres, but the maximum allowed is 35.56. So Chris's bag is not allowed on the plane. We don't even need to look at the height. Even if this one was fine, it would still not be allowed because the width is too big. So can Chris take this bag on the plane? We need to answer the question. So it's a big fat no. And the reason is the width is too big. And let's just put in brackets what the measurements were. So 40 centimetres is greater than the width, which is 14 inches. Okay, and we just proved that by converting it. Question 11, complete the two-way table. So we've got information here about eye colour and gender. So you always need to look to see what information you've got where there's only one piece missing. And I can see straight away that looking at the boys column, we've got all of the information here, but we've just got one cell that's missing. So we can work this out. If we know the total number of boys is 12, there were 5 that had blue eyes, 4 had green eyes, that's a total of 9. Then however many is left over must be brown eyes. So 5 plus 4 is 9. Take that away from 12 and we get 3. And now we've done this, I can focus on this column. This is just the total. So 3 plus 7 is 10. I can work out this one. So there's 9 green-eyed people in total. 4 of them are boys, so therefore 5 are girls. And notice you might have been doing this in a different order. There's usually a couple of different ways you could do it. I can work out this one. So 30 people in total, 12 are boys, therefore 18 are girls. I can work out this one now. So 18 girls in total, 12 brown eyes, 5 green eyes, that's 12 in total. Take that away from 18, we get 6 left over. And now we can do 5 plus 6 is 11. So that should be right. And let's just check the total by adding these ones. 11 plus 9 is 20, 20 plus 10 is 30. So these types of questions are very nice for picking up easy marks. So everything I did here, we get 3 marks for that. Question 12. There are 28 red pens and 84 black pens in a bag. Write down the ratio of the number of red pens to the number of black pens. Give your ratio in its simplest form. Okay, so we're writing out the ratio of the number of red pens to the number of black pens. Okay, so there are 28 red pens and there are 84 black pens. So the ratio of red to black is 28 to 84, but it's not as easy as that because we need to give our ratio in its simplest form. So think about what can we divide both of these numbers by? Well, straight away I can see that both of these numbers are in the 7 times table. Okay, if we divide 28 by 7, so if we divide 28 by 7, we get 4. And if we divide 84 by 7, we get 12. Now, I'm not going to stop there because this is also not in its simplest form. We can simplify this even further. So I can see that both numbers are divisible by 4. So if I divide both numbers by 4, 4 divided by 4 is 1. And then 12 divided by 4 is 3. And this is now definitely in its simplest form. So our answer is 1 to 3. A couple of things. Make sure you get them the right way round. So when you're doing ratios, read the question. It says red pens to black pens. So if you did write 3 to 1, that would be black pens to red pens. And you would lose a mark for that. So make sure the order is correct. And also make sure your ratio is in its simplest form. A lot of people might have just stopped here. So that is the correct ratio, but it's not in its simplest form. Okay, so this is the answer. Question 13. Here is a sequence of patterns made with grey square tiles and white square tiles, which we can see here. The first part says, in the space below, draw pattern number 4. So we can see pattern 1, 2 and 3. So let's first of all focus on the grey tiles. We've got 3 in pattern number 1, and then 4, and then 5. So if we continue the pattern, we're going to have 6 grey tiles. So 1, 2, 3, 4, 5, 6. And now let's look at the white tiles. We've got 1, then 2, then 3. So it looks like we're going to have 4. And notice the position of them. Okay, they're always in the middle. So we're going to have 4 in the middle. 1, 2, 3, 4. Let's just label this. So this is pattern number 4. Part B, find the total number of tiles in pattern number 20. Now, you could work out the total number in pattern 1, then 2, then 3, then 4, then 5, then 6, then 7, all the way up to 20. But that's going to be a bit arduous, and there's a much quicker way of doing this, and that is by using the nth term. So we've got the pattern number. Let's write down the pattern number here. So pattern number 1, 2, 3, 4, etc. And now let's work out the total number of tiles. So for pattern number 1, there are 4 tiles in total. Pattern number 2, there are 4 plus 2, which is 6. Pattern 3, well, there's 5 plus 3, which is 8. And pattern number 4, there's 6 plus 4, which is 10. So there is a nice pattern here. So they're going up by 2 each time. So what we can do is work out the nth term. So we know what it starts with because they're going up by 2 each time. So plus 2, plus 2, plus 2. We know the nth term is going to start with 2n. So it's similar to our 2 times table, but how much is being shifted up by? If you think about our 2 times table is 2, 4, 6, 8, but we've got 4, 6, 8, 10. So we need to add on 2. Okay, 1 times 2 is 2. We need to add on another 2 to get to 4. 2 times 2 is 4. We need to add on 2 to get to 6, and so on. So this is our nth term. So we can, if we just, for pattern number 20, that's just going to be when n equals 20. So it's going to be, for pattern 20, so for pattern 20, it's going to be 2 times 20 plus 2. Okay, so when n equals 20, it's going to be 2 times 20 plus 2. Well, that's 40 plus 2, which is 42. Okay, part C. Write an expression in terms of n for the number of grey tiles. Let's just highlight that. So write an expression in terms of n for the number of grey tiles. So we've done it for the total number of tiles. Now we just need to do it for the number of grey tiles. So again, let's write our pattern out. So our pattern number 1, 2, 3, 4. Now we're just focusing on the grey tiles. So pattern number 1, we've got 3 grey tiles. Then we've got 4. Then we've got 5. Then we've got 6. So our nth term. So what are we adding each time? Well, we're just adding 1. We're just adding 1. So it's just going to start with n. So if you think about our 1 times table, how much has it been shifted? Well, we're adding 2. To go from 1 to 3, we add 2. To go from 2 to 4, we add 2. To go from 3 to 5, we add 2. So we're just adding 2. So our answer is n plus 2. Question 14. A unit of gas costs 4.2 pence. On average, RIA uses 50.1 units of gas in a week. She pays for the gas she uses in 13 weeks. Work out an estimate for the amount Ria pays. So whenever you see the word estimate, always round your digits, the values you've been given, to one significant figure. Okay, so whenever you see the word estimate, think one significant figure. So 4.2 pence. We're not going to use 4.2 pence. We're going to use 4 pence. Okay, because I've rounded that to one significant figure. Now let's think about the amount she uses. So she uses 50.1 units. Okay, but we're not going to use that in our calculation. We're going to round this to one significant figure, which will be 50. So that's going to be 50 units. And she pays for the gas she uses in 13 weeks. Again, 13 weeks. We're just going to say that she pays for it in 10 weeks. Okay, because we're just going to round that to one significant figure. So now we've got all of our estimated values, we can answer the question. So we need to work out how much Ria pays for her gas. So in 1 week, let's just first of all work out the cost for 1 week. So each unit costs 4 pence and she uses 50 units in a week. So to work out the cost, it's going to be 4 pence times 50. Well, that's going to be 200 pence, which is the same as £2. So in 1 week, she spends £2, but we need to work out how much it costs, the total cost. So over 10 weeks, so 10 weeks, well, it's going to be £2 times 10. Well, 2 times 10 is £20. So our answer I'm going to give is £20. Now, just one thing that I need to point out is the answer is within a range. So if you put something else that's not exactly 20, you might still get the marks. So for example, if you didn't round the number of weeks from 13 to 10, if you kept it at 13 weeks and just did 2 times 13, so if you worked out exactly 13 weeks and did 2 times 13 to give you 26, that would also be fine. So both of these answers are fine, and if you've got anything in between these two answers, you would also get the marks. Okay, but anything less than 20 or greater than 26, you wouldn't get the full marks. Now part B says, is your estimate to part A an underestimate or an overestimate? Give a reason for your answer. So the value I got of £20 is definitely an underestimate. So underestimate. Okay, now if I leave it like that, you won't get any marks. Okay, even though it's only worth 1, it says give a reason for your answer. So the reason why it's an underestimate is because all of the values we rounded down. So all of the values were rounded down. Okay, so the true cost would actually be more expensive, okay, because we rounded down. The number of units we used should have been more because we rounded that down, and the number of weeks that is included in the cost should have been more. So everything resulted in a cheaper value, so we underestimated. Question 15. This is a scale plan of a rectangular floor, and I can see over here it says that the diagram is accurately drawn. So for this particular question, what I've done is I've printed off the question because you need to be really accurate, and I've got my ruler, so I'm going to do all of the measurements and then I'm just going to label them on this diagram. So we've been given a scale, so 1 centimetre on the piece of paper represents 2 metres in real life, and it says Mrs. Bridges is going to cover the floor with boards. Each board is rectangular in shape, and each board is 1.2 metres long and 1 metre wide. So it looks like we're going to cover this rectangular floor with boards that are something like this. So 1.2 metres wide, long, and 1 metre wide. So it says, let's move on. It says Mrs. Bridges has 150 boards. Does she have enough boards? You must show how you get your answer. Now the first thing I'm going to do is I'm going to measure this distance here of our rectangular floor. So I'm going to get my sheet of paper out and get my ruler out and measure the width of the floor, which is 10.5 centimeters. So let's write that down. So 10.5 centimeters. And now let's measure this length. So that is 3.5 centimeters. 3.5 centimeters. So that is the length of the scale, but we want to work out what the actual length is in real life. So to convert from our scale to real life, we multiply by 2 and then just change the units from centimeters to meters. So the width, we're going to do 10.5 times 2, which is 21. So it's 21 meters. And let's do the same thing with this length here. 3.5 times 2 is 7. So that is going to be 7 meters. So now we've got the length and the width of our room, we can work out the area. So area of, sorry, it's not a room, it's a floor. So area of the floor, well, that's going to be 21 meters times 7 meters. Well, 20 times 7 is 140. So it's going to be 147. 147 meters squared. So that is the area of the floor. Now let's work out the area of each board. So area of a board, well, it's going to be 1 meter times 1.2 meters. Well, that's just going to be 1.2 meters squared. So we've got the area of the board and the area of the floor, and Mrs. Bridges has 150 boards. So if we multiply the area of each board by 150, hopefully the total area will be at least 147. So we're going to do 1.2, and I can already see that it will be. So 1.2, we're going to do 1.2 times 150. Well, that is exactly the same as doing 15 times 12. And 15 times 12, 15 times 10 is 150. 15 times 2 is 30. And then 150 plus 30 is 180. So that's 180 meters squared. So that is, you know, what we've got. And the area that we need is 147. So we have more than enough. We've actually got, we're going to have a lot of boards left over. So does she have enough boards? Yes. And then I'm just going to put in brackets, 180 is greater than 147. Question 16. Work out the area of the shape. And this is worth 2 marks, this question. We've been given some of the dimensions, but we haven't been given all of them. So whenever you get a question like this, where it's a sort of a funny looking shape, always try and break the shape up. Okay, so what I'm going to do is I'm going to draw a dashed line down here. You could have drawn one across this way. It doesn't really matter which way you do it, but break it up into 2 rectangles. So this rectangle in here, well, I can see that it's going to be 2 times 10. The area of this rectangle is going to be 2 times 10, which is 20 centimeters squared. Now the area of this rectangle, this is where you need to be really careful, because it is not 8 times 2, because the 8 refers to this whole length from over here all the way up to here. This bit is not 8. So we're going to have to work out what this length is here. So this length. Well, I can see that the whole length is 8. This part here is 2. So this part here is 2 centimeters. So this part, we just need to take the 8 and take away 2. So it's going to be 8 take away 2, which is 6 centimeters. And now we can work out this area. So it's going to be 6 centimeters times 2 centimeters. So 6 times 2, and that is 12 centimeters squared. So the total area, well, it's going to be 20 centimeters squared plus 12 centimeters squared. 20 plus 12 is 32. So our answer is 32 centimeters squared. Just need to write 32 in here because the centimeter squared is already been given to us. Question 17. We've got a grid here, and it says on the grid, rotate the triangle 90 degrees clockwise about 0, 0. So there's quite a lot of information here. first thing to think about is the rotation. Now, for this particular question, you will need to print this off, and preferably you'll use some tracing paper. Now, in your exam, you should always ask for tracing paper. If there isn't any given to you, make sure you ask, because they will give it to you, and you will need it for any rotations. Okay, so we are going to put our tracing paper over our triangle, and make sure when you put it over the triangle, it also goes over the center of rotation. So our center of rotation is 0, 0. So that is, let's do it in black. So that point there is the center of rotation. So your tracing paper, when you get your tracing paper, it should cover all of that. Okay, so it should cover the triangle and the center of rotation. So we're going to rotate it clockwise. So that is in this direction, and we're going to go 90 degrees. Now, I've already done this on my piece of tracing paper, and I'm just going to do it in a different color. So this point here should map to this point. This point here should map to this point. This point here should map to this point, and then we just need to connect all of the points together. So that should be our final answer like that. Question 18. There are 500 passengers on a train. 7/20 of the passengers are men. 40% of the passengers are women. And the rest of the passengers are children. Work out the number of children on the train. So let's first of all work out how many men there are on the train. So the number of men. So there are 500 passengers, and 7/20 are men. So to work out the number of men on the train, well, we can just do 7/20 multiplied by 500. Now, instead of writing 500, I can write that as a fraction. So I can just write that as 500 over 1. Okay, now you could multiply across, but I'm just going to make things a bit easier and simplify. So I can see that both of these numbers are divisible by 10. So if I divide that by 10, I get 50. If I divide that by 10, I get 2. And now again, I can see that both of these numbers are divisible by 2. So if I divide 50 by 2, that becomes 25. If I divide that by 2, that just becomes 1. And now it's fully simplified. We can multiply across. So 7 times 25, well, that is 175, I believe. Yeah. Because 8 times 25 is 200, so take away 25. And then on the bottom, we've just got 1 times 1, which is 1. That's 175 over 1. Well, that's just 175. So there are 175 men. And now let's work out the number of women. So women, well, it's going to be 40% of 500. So it's going to be 0.4 times 500. I just converted that to a decimal. So 4 times 500 is 2,000, but it's 0.4, so it's going to be 200. So there's 200 women. So the total, so I'm just going to put M plus W for men and women. Well, that's going to be 200 plus 175, which gives us 375. And there's 500 passengers in total. So the number of children, we can just take that away from 500. So 500 take away 375, and we are left with 125. So our answer is 125. Question 19. A shop sells milk in 1-pint bottles and in 2-pint bottles. Each 1-pint bottle of milk costs 52 pence, and each 2-pint bottle of milk costs 93 pence. Martin has no milk. That's very sad for him. He assumes that he uses on average 3/4 of a pint of milk each day, and he wants to buy enough milk to last for 7 days. Work out the smallest amount of money that Martin needs to spend on milk. You must show all your workings out. Right, so there's quite a lot of information that we've been given. So he uses on average 3/4 of a pint of milk each day, and he needs enough milk to last him 7 days. So how much milk does he need? So let's write up here milk needed. So the amount of milk he needs, well, it's going to be 3/4 of a pint multiplied by 7 days. So what is that? Well, 3 times 7 is 21. So it's going to be 21 out of 4 pints of milk. But just to make things a bit more meaningful, let's write this as a mixed number. So 21 divided by 4 is 5. So that's the same as 5, and there's 1 left over. So it's going to be 5 1/4. So he needs 5 1/4 pints of milk. So should he buy the 1 pint bottles or the 2 pint bottles? Well, looking at the prices, it makes more sense to buy the 2 pint bottles, because if we were to buy 2 of these ones, that would work out more expensive than 1 of these. So we'll try and get as many 2 pint bottles as he needs. So if he bought 1 of them, that would be 2 pints. If he bought 2 of them, that would be 4 pints. But he needs at least 5 1/4. Well, you can't buy them in quarter pints. You'd have to round that up to 6. So he'd have to buy 6 pints. And he can do that by buying 3 of these. So if he bought 3 of these ones, that would be 6 pints. So how much is he going to spend? Well, it's going to be 3 times 1 of these. So each 2 pint bottle costs 93 pence. So 3 times 93 pence. So 3 times 90 is 270. So that's going to be 279. 279 pence, which is the same as £2.79. So that is our answer. Our answer is £2.79. Okay, moving on to part B. Martin actually uses more than 3/4 of a pint of milk each day. Explain how this might affect the amount of money he needs to spend on milk. So basically, that he's saying that he doesn't use 3/4 of a pint, he uses more than 3/4 of a pint. So if he's drinking more milk, it's likely that it's going to be costing him more money. So we can say that if he uses more milk, he may spend more money. That's all we need to write. It's only worth 1 mark, this one. So if he uses more milk, he may spend more money. And the reason I've put may is because he won't definitely spend more money, because he may need 5 3/4 of a pint of milk, and in that case he'll still only be paying the same amount. So it's only if he goes over 6 litres. So I could add that. I don't need to add it, but I'll just add it just because I think it'll make a bit more sense. So I'll just put in brackets, if he goes over 6 litres per week. Question 20. The diagram shows a right angle triangle. All of the angles are in degrees. Work out the size of the smallest angle of the triangle. So the key thing to remember here is that angles in a triangle sum to 180 degrees. So if we add up all of the angles and set that equal to 180 degrees first of all. So I know that this angle is 90. So we're going to have 90 plus this angle. Well, we don't know what that angle is, but we know that the expression for that angle is just 7x. Plus this angle, which is 5x plus 18. So when we add all of these angles together, that should come to 180 degrees. And now we just have an equation to solve. So let's first of all simplify this. We've got 7x plus 5x. Well, that gives us 12x. And then we've got 90 plus 18. Well, that gives us 108. And that equals 180. And now if we subtract 108 from both sides, we're left with 12x is equal to 72. And now if we divide both sides by 12, we get x is equal to 6. So we're not done. We found our value for x. We just need to substitute this back into our expressions to work out what the different angles are. So this angle, let's do 2 arrows, one going there and then one going here. Because we know this is 90. So this angle here, well, that's going to be 7 times 6. So 7 times 6, well, that's 42 degrees. So this angle here is 42 degrees. And then this angle is going to be 5 times x, which is 6. So 5 times 6 and then plus 18. So 5 times 6 is 30. 30 plus 18 is 48. So that angle is 48 degrees. So we've got all of our angles now. Work out the size of the smallest angle. Well, this one is the smallest, so that is 42 degrees. Question 21. A box exerts a force of 140 newtons on a table. The pressure on the table is 35 newtons per meter squared. Calculate the area of the box that is in contact with the table. And we have been given the formula that associates pressure with force and area. So we need to calculate the area. So let's just rearrange this formula so that it's in terms of the so it's to make the area the subject. So the area is going to be the force divided by the pressure. Okay, you could think about it, a lot of people like to use these triangles. So if we've got pressure, force and area, we can see that the pressure is the force divided by the area. The force is the pressure times the area, and the area is the force divided by the pressure, which is what we've got here. So we've got the force. Well, the force is 140 newtons, so 140 newtons, and we're going to divide that by the pressure, which is 35 newtons per meters squared. So what's 140 divided by 35? Well, I can see that that is 4. I don't need a calculator for that. So 4, and then our units, we need to think about our units. Well, our units are going to be meters squared. So that's the only unit we've got left here. If we think about what units areas are measured in, areas are measured in units squared, and we're dealing with meters. So our answer is 4 meters squared. And we need to make sure we include our units, because this question, or the answer line, does not have any units. So if you don't put meters squared, if you just put meters, or if you put some other units, you will lose marks. So make sure you include your units. Question 22. There are only red counters, blue counters, green counters and yellow counters in a bag. The table shows the probabilities of picking at random a red counter and picking at random a yellow counter, which we can see here, these probabilities. The probability of picking a blue counter is the same as the probability of picking a green counter. Complete the table. So these two values are the same. Now, we know that the probability of all outcomes of mutually exclusive events is 1. So these 4 values should add up to 1. So if we add these two values first, so 0.24 plus 0.32, so 4 plus 2 is 6, 2 plus 3 is 5, so that gives us 0.56. And now we just take this away from 1, that will give us what's left over. So if we do 1 take away 0.56, well, that gives us 0.44. So these two things have to add up to 0.44, and we know they're the same. So if we just do 0.44 divided by 2, well, that gives us 0.22. So that is our answer for these boxes, 0.22. And you can check this. If you add up all of these values, it should equal 1. And that is our answer. So it says complete the table. We have done it. So we've got 0.22 in both boxes. Question 23. A pattern is made using identical rectangular tiles. Find the total area of the pattern. Okay, so we know that this length is 7 centimeters, and that includes the length of a rectangle plus the width. So if we just label this the length and this the width, we can say that the width plus the length is equal to 7. Okay, now we've also been given this information up here. So that 11 centimeters, what does that correspond to? Well, that corresponds to one length plus another length plus a width. So we can say that a width plus 2 lots of the length, so 2L, well, that is equal to 11. So notice now we've got 2 equations with 2 unknowns, so we can actually solve these pair of simultaneous equations. And there are many ways we can solve simultaneous equations. We could use the elimination method or the substitution method. I'm going to use the substitution method. So if I just rearrange this equation, so I'm going to put it in terms of W, or sorry, I'm going to make W the subject. So it's going to be W is equal to 7 minus L. I just subtracted L from both sides. And now we've got an expression for W. We can substitute this into this equation. So instead of writing W, we can write 7 minus L. So it's going to be 7 minus L plus 2L is equal to 11. So 2L minus L, well, that's just L. So it's going to be 7 plus L is equal to 11. Therefore, L is equal to 4. So now we know our value for L. Well, W is going to be quite easy because we can just use this top one up here. So if L equals 4, that means that W must equal 3, because 3 plus 4 is equal to 7. So we found our values for L and W, our length and width. Now we can work out the area. So the area, well, there's 4 tiles. They're all identical. So it's going to be 4 times the area of one of the tiles. So the area of one of the tiles, well, it's just going to be 4 times 3. So 4 times 3. This is the area of one tile, and we've got 4 of them. So 4 times 4 times 3. Well, 4 times 3 is 12. 12 times 4 is 48. So our answer is 48, and it is in centimetres, so it's going to be centimetres squared. So that is our answer, 48 centimetres squared. Question 24. The diagram shows a sandpit, and the sandpit is in the shape of a cuboid. Sally wants to fill the sandpit with sand. A bag of sand costs £2.50. There are 8 litres of sand in each bag. Now, Sally says the sand will cost less than £70. We need to show that she is wrong. So we've been given the dimensions of the sand pit. So let's work out the volume of the sand pit. So the volume of the sand pit, so let's write this down. So volume of pit, well, that's going to be 40 centimetres times by 100 centimetres times by 60 centimetres. So what is all of this? Well, 4 times 6 is 24. It's going to start with 24. Now let's just see how many zeros we've got. 1, 2, 3, 4. 1, 2, 3, 4. So, and that is going to be in centimetres cubed. So the volume of our sandpit is 240,000 centimetres cubed. Now, if we're looking at how much sand is in each bag, they've given it to us in litres, but we can convert that into centimetres cubed, because 1 litre is equal to 1,000 centimetres cubed. So obviously this is a conversion that is not given to you. So you do need to know this. So basically the easy way to think about this is a litre box. So a litre box is just 10 centimetres by 10 centimetres. Oh, 10 centimetres by 10 centimetres. So if we work out the volume of that, that is 1,000 centimetres cubed. So if we just convert 8 litres into centimetres cubed, well, we just multiply by 1,000. So 8 times 1,000, 8 times 1,000, well, that is going to be 8,000 centimetres cubed. So that is the amount of sand in each bag. Now we need enough sand to fill this volume here. So to work out the number of bags, so number of bags, well, we're just going to do this divided by this. It's going to be 240,000 divided by 8,000. Okay, so we can take off the thousands. So it's just 240 divided by 8, which is 30. So we need 30 bags. Right, now let's look. We know the cost of each bag. So a bag costs £2.50. So to work out the total cost, well, it's going to be 30 multiplied by £2.50. So £2.50 times 3 is £7.50. So it's going to be £75. £75. Okay, now we've got the total cost. We can answer the question. Sally says that the sand will cost less than £70. Well, no, she is definitely wrong. The sand will cost more than £70. It will cost £5 more. So show that Sally is wrong. So we can just say that Sally is wrong because £75 is greater than £70. And we're done. Question 25. 4 friends each throw a biased coin a number of times. The table shows the number of heads and the number of tails each friend got. So we can see that the person flipping the coin is up here and the number of heads and tails they got is down here. The coin is to be thrown one more time. Which of the friends' results will give the best estimate for the probability that the coin will land on heads? And we must justify our answer. So whenever you're asked about what's the best estimate to use in terms of probability, always choose the person with the most number of trials. Okay, or always choose the experiment that has the most number of trials. So it doesn't matter what their results are. Whoever did the most number of trials will have the most reliable data. So in this case, it is Sharif. So that is going to be our answer. Okay, it doesn't matter what numbers he got here. There's just the fact that he's done the most number means that his data is the most reliable. So Sharif, and we must justify our answer. We can just say that he did the most trials. He did the most trials. And that will give us the marks. Okay, moving on to part B. Paul says, with this coin, you are twice as likely to get heads as to get tails. Is Paul correct? Justify your answer. Now, he's saying that it's twice as likely to get heads. Now, you might be tempted to say that he's correct, because if you look at Paul's data, well, he's flipped heads 80 times and tails 40 times, and that is twice as much, so it would be twice as likely. But the mistake here is that we're only using Paul's data. We need to use data where there's more trials. So we could either use Sharif's data, or an even better thing to do would be to combine everyone's data together and use that data. Okay, so is Paul correct? We'd have to say no and justify your answer. So we can say that he only used his data. Okay, so we could say that what would happen if he used all of the data. Let's work that out. So let's work out the total. Okay, so if he used all of the data, how many heads were flipped? Well, 120 plus 80 is 200, plus another 100, that will give us 300. And the number of tails, well, that's 40 plus 40 is 80, plus 20 is 100. So if he used all of the data, well, we can see that it's going to be around 3 times as likely. So if he used all of the data, we can say that if he used all of the data, it would be approximately, I'm not going to say exactly because this is only an experiment, approximately 3 times as likely. Okay, so it's not twice as likely, it's more likely to be 3 times as likely because we're using more data. Okay, moving on to part C. The coin is to be thrown twice. Use all of the results. So now we're told explicitly that we have to use all of the results to work out an estimate for the probability that the coin will land heads both times. So it has to land heads on the first and heads on the second. So we're going to work out the probability of getting heads and then heads. So what is the probability of getting heads once? Well, it's going to be 300. So probability of getting heads once is going to be 300 out of the total, which is 400 because there are 100 tails, and that is exactly the same as 3/4. So it's going to be 3/4, but then he needs to get heads on the second flip as well, so that's going to be 3/4 times by 3/4. So 3 times 3 is 9, 4 times 4 is 16. So that is our answer, 9 out of 16. The reason why these are the same is because the first flip has no influence on the second flip. They are independent events. It's not like we're taking a marble from a bag and then taking another marble. Okay, every flip, the probability is going to be the same. So that's why these values are the same. So this is our answer here. Question 26a. Write down the exact value of the cos of 30 degrees. Now, the cos of 30 degrees, that's one of our trig ratios. And this is where it starts to get into the higher territory. So it's just something that you would need to memorize, really. So the cos of 30 degrees, well, that is root 3 over 2. I'm just doing this from memory. So it's just root 3 over 2. There is a slightly longer method that you could do to work out the answer. But for these questions, really, you just want to memorize what these trig values are. So that is our answer, root 3 over 2. Okay, part B. Given that the sine of 30 degrees is equal to 0.5, work out the value of x. So we've got a right angle triangle here, so we're going to use some trigonometry. And in particular, because we've got a right angle triangle, we can use SOHCAHTOA. So if I just write this down, SOHCAHTOA. So what have we got? Well, this is our angle. So we've got the opposite and we've got the hypotenuse. So which one involves the opposite and the hypotenuse? Well, it is this one here, which is sine. And I kind of hinted it because we've got the sine over here. So the sine of our angle, so we can say that the sine of 30 degrees is equal to the opposite. So x divided by the hypotenuse, which is 12. But we know what the sine of 30 degrees is. We're told that. So fortunately for us, we're told, if you might have already known that. You might have already known that it's 0.5, but if you didn't, then it's given to us. So we can just replace sine of 30 degrees with 0.5. So we can say 0.5 is equal to x over 12. So to work out what x is, we can multiply both numbers by 12. So 0.5 times 12 is 6. Our answer is 6. X equals 6. Question 27. Expand and simplify this expression here. So I'm just going to write it down below. We've got x plus 3 multiplied by x minus 1. So whenever we've got double brackets, I like to use the FOIL method just because it's a bit quicker. So x times x, well, that will give us x squared. X times negative 1, well, that's negative x. And then 3 times x, well, that's positive 3x. And then 3 times negative 1, that is minus 3. So we have done the expanding part, but we just need to simplify this. So we've got x squared minus x plus 3x, well, that's plus 2x, and then minus 3. So this is fully simplified now. So that's our answer, x squared plus 2x minus 3. Question 28. Factorize this expression here. Now, whenever you've got an expression like this is known as a difference of squares. Notice how both of these terms are square numbers. So x squared, well, that's just x squared, and then 16 is 4 squared. So there's a quick way to write a difference of squares. Is this would just be x plus 4 and then x minus 4. And how I got that is we just take the square root of both numbers. So the square root of x squared is x, the square root of 16 is 4. In one of them we put a plus, in the other one we put a minus. So that is our answer. Our answer is x plus 4, x minus 4. And we can check this. What I'll do is I'll just quickly expand the brackets just to prove that we will be left with this expression here. So x times x, that gives us x squared. X times negative 4 is negative 4x. 4 times x is positive 4x. And then 4 times negative 4 is negative 16. And then notice that these two terms in the middle will cancel out. Negative 4x plus 4x, well, that is just 0. So all we're left with is x squared minus 16. Question 29. Solve the simultaneous equations. Now, I did solve a pair of simultaneous equations before, but this is a question specifically about on that topic. So just like before, there's two different ways we could solve this. And again, I'm going to use the substitution method just because looking at the what we've got here, I think it will be slightly easier. So what I'm going to do is I'm going to take the second equation and I'm going to make x the subject. So if I subtract 3y from both sides, I'm going to be left with x is equal to 3y plus 16. All I've done is I've just rearranged this equation to make x the subject. And now I've got an expression for x. I can substitute this back in to my first equation. So wherever I see an x, I can replace that with 3y plus 16. So we're going to have 4 times x. Well, so it's going to be 4 times 3y plus 16. And then plus y, and that equals 25. So let's just expand the brackets. So 4 times 3y is 12y. And then 4 times positive 16 is 64. And then plus y equals 25. Now if we combine like terms, 12y plus y, well that is 13y, plus 64 equals 25. And now if we subtract 64 from both sides, we get 13y is equal to negative, what's that, 39? 64 minus 25 is 39, so it'll be negative 39. And then divide both sides by 13, we get y is equal to negative 3. So now we have our value for y. We can substitute this into any one of our equations. I think I'm going to use the top equation. So we've got 4x plus y. So that's just y. We know y is negative 3. So it's just going to be 4x minus 3 is equal to 25. Now if we add 3 to both sides, we get 4x is equal to 28. And now divide both sides by 4, we get x is equal to 7. So we've got our values for y and for x. So let's just write these in. X is equal to 7, y is equal to negative 3. And that was the last question. You will be pleased to know. So there was a lot to get your teeth into in that paper. So how did you get on? Hopefully my workings out helped you. If there are any topics that you struggled with, please let me know in the comment section. Write down any questions that you've got and I can address those in future videos. And like I said before, I'm going to do paper 2 and paper 3, which are the calculator versions. So please join me for those. I'm sure we'll have a lot of fun doing those as well. And I will see you in the next video. Take care.